Hello everyone, welcome to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Punguri, MSc MPhil Mathematics from CD King Higher Secondary School, Jotsama, Kohima. In the last session, we learned what are the types of sets. In this session, we are going to learn what is a subset and a power set. Okay, subset. Let X denote the set of all class 11 students in your school. Okay. And let Y denote the set of all students in your school. I am sure that every student of this set will also be a student in this set also, right? We count them here also. So all the students, all the elements in this set will also be an element in this set. So here we call it as X is a subset of Y. This is called subset symbol, okay? Not like C but little bit longer, no? C, and followed by a line. I'll explain to you why we are putting this line later. Okay, so here X is a subset of Y. So this X is subset and Y is called the superset. X is contained in Y and Y contains X. Okay, so otherwise we can write this one. A is a subset of B if A belongs to A implies A belongs to B. You can remember this. This is the definition for the subset. A is a subset of B if A, small a, is an element in this set, which implies that A is also an element in B. Then only we can say that A is a subset of B. Not only for one element, every element of A. I will give you more examples. A is 1, 2, 3 and B is 1, 2, 3, 4, 5. See here. See, every element of A is also an element of B. 1, 2, 3. Here also 1, 2, 3 is there. Here we say that A is a subset of B. And if we note that A is a subset of B, but A is not equal to B, right? A is not equal to B. Yes or no? See, it doesn't have the same, exactly the same elements of B. But it is a subset. In this case, we can say that A is a proper subset of B. Okay, proper subset. If you don't put that line, we call it as proper subset. Proper subset. Okay, what is the condition for being a proper set? A is a subset of B, but A is not equal to B. And what is the difference between these two? This means, suppose AB we take. A may or may not be equal to B. Alright, may or may not be equal to B. When we define some unknown sets, so we can say that we can put this symbol, no harm in it. But if you put this one, we definitely know that it is not equal. Then only we can use this symbol. Then this is a proper subset of B. Okay. And here, let me take another example. A is ABC and B is BCA, right? A is a subset of B, right? Okay. And B is a subset of A. Yes, because all the elements of A are in B and every element of B are also in A. Therefore, A is a subset of B and B is a subset of A. So, which means A is equal to B. This symbol should be read as if and only if. If and only if. This is implies. This should be read as implies. Okay, and this is subset. This is if and only if. That is, if A is a subset of B and B is a subset of A, then A equal to B. If you take the reverse, for example, if A is equal to B, then A is a subset of B and B is a subset of A. So both wise it satisfies. Therefore, we put this symbol if and only if. I double F. This should be read as if and only if. Okay. Then, for example, A, here if you take A equal to -1, 0, 1 and B as ABC. See, here A is not a subset of B and B is not a subset of A. Okay, this represents it is not a subset of B. B is not a subset of A. All right. Then we will see some subsets with the known symbols. Already we have we have learned these symbols N for natural numbers and Z for integers and Q for rational numbers, the set of all rational numbers, and R for the set of all real numbers. Okay. So here N is a subset of Z, right? Here we can use this proper set. Yes or no? It will never be equal to Z, but it is a proper subset of Z, and Z is a proper subset of Q, and Q is a proper subset of R, right? And I already told you T, that is the set of all irrational numbers. N, is it a subset of T? No, right? So we can put this symbol. It is not a subset of irrational numbers, but T is a subset of R. The irrational numbers contains the real numbers contains the irrational numbers. Therefore, we can put this symbol. So this is the superset when you compare these two, and when you compare these two, this becomes superset, and this is subset. All right. Then next, we will see some intervals. How to write the intervals? Intervals as subsets of R. R for real numbers. Okay. So we know how to draw a real line, isn't it? Okay. So let me take two real numbers, A and B. B, two real numbers. Okay. And A less than B. In such a way we choose two numbers. See, this is the real number, right? Real number line. This is infinity and this is plus minus infinity, and 0, 1, 2, 3, etc. And here -1, -2 and -3, etc. Here I am writing only the integers, but you know between every two real numbers there are infinite number of real numbers. Yes or no? Here if you take 0 and 1, in between this 0 and 1 we can find out infinite number of real numbers that you have learned already. So it is not possible for us to write all the real numbers on the real number line. So I am taking only the integers. If we choose A as 1 and B as somewhat 10, okay, so 1 is less than 10, right? So we are going to choose in that way two real numbers. Okay, there are 4 intervals. The first one is with the closed bracket, right? The other one with open bracket. Sometimes in some textbooks they use this symbol also, open bracket. Okay, and the other one is left closed and right open, and this is left open, right closed. Okay, so how are we going to define this? Is the set of all x such that A less than or equal to x less than or equal to b, and this one is the set of all x such that A less than x less than b. All right, and here is the set of all x such that A less than or equal to x less than b, and this one x such that A less than x less than or equal to b. Okay, What is the difference it is making by putting this equal with less than and without equal sign? That means the extreme points also we will include it when we take. For example, if we take 4, no? A is 1 and B is 4. That means from this point to 4, we take all the real numbers in between. From 1 to 4, whatever we have, all the real numbers we will take, including the extreme points 1 and 4. We will include 1 also. That means 1, 1.1, for example 1.11 or 1.2, 1.5, etc. 2, 2.1. See, in this way, no, we can take all the numbers until 4. From 1 to 4 we take all the numbers, that is closed bracket. We will include the extreme points also. And here we will not take the extreme points but the next succeeding number with the preceding number of B. For example, here for your understanding I am writing in decimals. We will not take this 1 and 4. We will exclude this 1 and 4, but we take all the numbers in between. For example, from 1.1 to 3.99999 like that. Okay, so we will not take the extreme points for the open bracket. That's why we are not putting that equal sign. If you put the equal sign, that means the extreme points also included. Okay, in that case, we draw the line as like this, hollow circle. It means we will not take this 1 and 4, but in between all the real numbers we take. Okay, now hope you can understand these two. Left side closed and the right side open. In this case, we will include this 1, but we will not take this 4. That means 1, from 1 we will choose, but we will exclude 4. So that is the meaning of this left closed, right open. And left open, right closed. That means here we will exclude 1, but we include this 4 also. So 1 we won't take, but 4. The right side we take. Hope you understand. If you put that equal sign, that means that extreme points is included. Okay. So this type of intervals you will often find it in your textbook. Next one, we will move on to power set. Power set. That means the set of all subsets of a set. For example, A. The set of all subsets of a set A is called the power set of A, and it is denoted by P of A. Power set of A. Okay, the set of all subsets. Previously, when we learned the subsets, obviously the empty set is a subset of every set, isn't it? And also the every set is a subset of itself. For example, A is 1, 2, 3, right? Phi is a subset of A. Yes or no? And A is a subset of A. These two are very important results. Please remember this. So empty set is a subset of A, and every set is a subset of itself. Okay, empty set is a subset of every set, and every set is a subset of itself. Okay. Here for this power set, the set of all subsets of a set A is called the power set of A, and it is denoted by P of A. So let us take A as 1, 2. Alright. Okay. Then let us write P of A, that is power set. So what is the definition of power set? The set of all subsets of A. The first one is phi, because we know that empty set is a subset of every set, therefore phi will be the first subset. Then 1 is a subset of 1, 2 or not? Yes. And then 2 is a subset of 1, 2. All the possible subsets we have to write. And then 1, 2, because every set is a subset of itself. You see here, in here every member of the power set is also a set. So don't get confused. Here every set should have a, every member should be a set. See, we have brackets. Okay. And let us take A as 1, 2, 3. Let me take ABC. A, B, C. And here P of A will be, the first one will be 5, and here A, B, then C, and we have AB, right? And then BC is also a subset, and CA, this is also a subset, and finally ABC, the set itself, right? Don't forget to put the brackets and also the commas in between. And here how many we have? N of P of A is 4, right? 1, 2, 3, 4, 4 elements. And here N of P of A is 1, 2, 3, 4, 5, 6, 7, 8. So 8. So can we write this one as 2 square and this one as 2 cube? Yes. So in general, the number of elements in the power set can be written as 2 power m if m is the number of elements in set A. This is a very important result. We will be learning more like this. Okay, the number of elements in the power set will be equal to 2 power m. M is nothing but the number of elements in set A. Suppose set A has 4 elements, then you will put 2 power 4, so 16. So you will get 16 subsets for this. Okay, so you can try with 4 elements also. All right, and then here P of A. Please don't get confused with this symbol and this symbol. All right, this is belongs to, this is belongs to, and this is subset. Okay, here it will be a set, here it will be a set. Okay, but this will be an element. The left side will be always an element, and this is a set. This is element and this is a set. But here subset means both will be sets. We can use this symbol between 2 sets only. We can use this symbol with one element and the other set. For example, 1 belongs to A, right? But set 1 subset of A. Hope you understand this. See, this is an element and this is a set, and this is a set and this is a set. Okay, students will often get confused with these 2 symbols only. Then the last one is universal set. Last one is universal set. Universe contains everything, right? So universal set, for example, A is 1, 2, 3, B is 2, 3, 4, 5, and C is 6, 7, 8, 9, right? If we can find a superset which contains all these sets, okay, so that is denoted by U. It may be 1, 2, 3 till 10 or 9 also. You can put 9 also, isn't it? Otherwise, the set of all x such that x is a natural number. See, this is a superset of these 3 sets. This is also a superset of these 3 sets. So therefore, the universal set is not unique. According to our convenience, we choose the universal set. Okay, and it should be in the particular context we define the sets. For example, for this U, we cannot take A, B, C, D, E, F, G as the universal set. Yes or no? Because it is not defined in the same context. Therefore, but in the particular context, we have to take the universal set, and universal set is not unique. Okay, and this is the superset of all the sets. Okay, today we learned what is a subset, what is a proper subset, and what are the intervals as subsets of R, and what is a universal set. In the next session, we will be learning what is Venn diagram and the operations on sets. Thank you.